Hey guys, today I'm going to be talking about the epinephrine and glucagon pathway that I'm learning in my Bio 2 class, so it's not too much in detail. It involves a GPCR receptor here, which stands for G protein coupled receptor. So basically this right here is a glycoprotein made out of 7 segments of alpha helixes. So you have 7 alpha helix segments. The entire thing's a glycoprotein, by the way. And so you'll have a first messenger bind to the active site right here. And this first molecule right here can be either epinephrine or glucagon. And the final result of this pathway is to increase your blood sugar. So let's say this is epinephrine. Once this binds to the active site of one of the alpha helixes, it's going to activate this G protein molecule down here, which is binded to one of the alpha helixes on the cytoplasmic side. So basically the G protein will go from inactive to active. So basically it's going from GDP to GTP. So GDP to GTP. GDP is its inactive form and GTP is its active form. Over here next to it, you're going to have its effector enzyme. In this case, in this pathway, the secondary messenger that's being produced is CAMP. And what produces CAMP is this effector here called adenylyl cyclase. So this is going to produce your CAMP. So in order for it to produce the CAMP, the G protein that's activated has to bind on this active site over here, right? And it will activate the effector enzyme whenever it will hydrolyze the GTP back to GDP. So whenever it does that, it activates the effector. Activating the adenylyl cyclase will produce CAMP, which stands for cyclase AMP. So it's a cyclase AMP. So what cyclase AMP will do is it will activate a thing called protein kinase A. So in short, it's pKa. Oops. pKa. So this protein kinase A. So what protein kinase A will do, it's going to do two things. First, it's going to phosphorylate an enzyme called phosphorylase. And then it's also going to phosphorylate an enzyme called glycogen synthase. And we're going to get back to that later. So essentially, this phosphorylase will phosphorylate another molecule called glycogen phosphorylase. Now what this will do is it's an enzyme responsible for cleaving off the subunits of glycogen. So it's going to cleave off glucose 6-phosphate subunits. So let's say you have a molecule of glycogen here. Right, so it's all these subunits of glucose. So this glycogen, it's basically going to take off the subunits of this glycogen. It's going to take off these glucose 6-phosphates. And it's going to release these into your bloodstream so your blood sugar increases. So each one of these circles is a glucose 6-phosphate. It's a subunit of glycogen. So at the same time, whenever you phosphorylate the phosphorylase from protein kinase A, you're also going to phosphorylate glycogen synthase. Now, keep in mind that phosphorylation doesn't equal activation. It can also equal inhibition. So in this case, glycogen synthase is going to inhibit the formation of glycogen from glucose subunits, right? So it inhibits glycogen forming from glucose subunits, right? So that's the pathway of this epinephrine and glucagon pathway. Ultimately, the end goal, as you can see here, is that we're releasing the glucose 6-phosphate subunits into the bloodstream via this glycogen phosphorylase down here. So this is going to increase your blood sugar in the end, but at the same time, you're stopping the production of glycogen with this glycogen synthase right here. And that's the pathway of epinephrine and glucagon pathway.